Today we're looking at law of sines again. Your essential question is, how do I find missing measures with the law of sines? Your learning intention: I'm learning to find missing measures using the law of sines. So, solve for the missing measures. The first two, the warm-up questions, are actually using trigonometry. So, pause the video, remember SOHCAHTOA, and solve the first two problems. So if you can't remember, you write SOHCAHTOA out at the edge. So, sine, opposite, hypotenuse. Cosine, ka. Adjacent over the hypotenuse. And finally, there is tangent, which does not use the hypotenuse. TOA. Okay, so if you're looking at this, which two pieces do we have? Here's my angle, opposite, hypotenuse. Opposite and hypotenuse is sine. So the sine of 46 degrees is equal to 8 divided by x. What do we do when our variable's at the bottom? Remember that flip-flop? We flip them around. X is equal to 8 divided by the sine of 46 degrees. Putting it into our calculator. And you end up with about 11.1. Now, to be more accurate, we'd go out several more decimal places, but we're just making sure you know the technique this time. So, looking at the next one, we're looking for an angle measure. So, we still set it up the same way. This time we've got what? Here's the angle I'm looking for. I've got my hypotenuse. Adjacent or opposite? Adjacent. So the cosine of theta is equal to 52 divided by 56. What button do we use? Our inverse button. Cosine inverse of 52 divided by 56. You notice I don't even simplify because I don't need to. And this is approximately. Second, cosine 52 divided by 56, close it off. 21.78, 21.8 degrees. And this brings us to the law of sines again. And this is for non-right triangles. I just put the one that I like to use the best here. Now you can also do the reciprocals if you would like. If you'd rather have your side measure on top, that's fine. So we're going to solve the first one. We've got two of the three angles. What do we do to find that third angle? We will take 180 degrees minus 53 degrees plus 44 degrees. And that will give us what? 83 degrees. So this is 83 degrees. Now we've got to make sure that we've got those matching pairs. I've got B and I've got side B, angle B and side B. So I have to start with them every time. So the sine of 45 degrees, or 44 degrees, is over 7 is equal to the sine. Do you want to find A or B first? This will be A. Oh, I guess we have B. It's A or C. A first? Okay. So A is 83 degrees over A. So we start with that cross multiplication. The sine of 83 degrees. Remember, we can't put the degree symbol in, we just put the number, times 7 divided by the sine of 44 degrees. Once again, this will be an approximation. So the sine of 83, close it off, times 7 divided by the sine of 44, close it off, 10. So it's about 10. And now, for the last one, for C, you still start off with the same fraction. The sine of 44 degrees over 7 is equal to the sine of 53 degrees over C. Okay, looking at these, which is going to be bigger, B or C? Angle C is greater than angle B, so C will be greater than side C will be longer than side A, or side B. So let's set it up. Cross multiplication. The sine of 53 times 7 divided by the sine of 44. So I just did a second and enter and got the same equation back down and just changed one number. And this is 8.04, so that is about 8. Eight is greater than 7. If you're looking, 83 is the biggest one, and side 10 is the biggest side. Okay, largest angle, largest side. Middle angle, middle side, smallest angle, smallest side. And it will be that way all the time. Your largest side will be across from your largest angle. Okay, pause the video and see if you can do the next, at least find that third angle on your own. I hope you tried. So it will start out 180 degrees minus 51 degrees plus 39 degrees is equal to 90 degrees. I have a right angle. Now, am I going to use the law of sines? No, I'll use the trigonometric ratios. So if I'm looking for, I've got the hypotenuse. So I'm going to use either sine or cosine to find those missing measures. If I'm at angle 39, this will be side A and this will be side C. So 39, my hypotenuse, and my opposite is sine. So the sine of 39 degrees is equal to A divided by 27. I've divided by 27. How do I undo that? Multiply by 27. Sine of 39 times 27, 16.99. A is about 17. Now, if I wanted to, I could use the Pythagorean theorem. But it's just as easy to use the law of cosines, or use the cosine ratio. We're looking for the adjacent. So the cosine of 39 degrees is equal to C over 27. Once again, I've multiplied by 27 to get rid of it, of the dividing by 27. And we get 20.98, which is approximately 21. So how close are we? Let's look. 17 squared plus 21 squared, I get 730. 27 squared gives me 729. Pretty close. Okay, for the last one, pause and see if you can set up. Can we find that third angle with the triangle sum theorem? No. So we're looking for angle B and we're looking for angle C. This would be side B and this would be side C. We still set it up the same way with those fractions. So the sine of 103 over 26 is equal to the sine of B over 24. Which one's going to be bigger? Well, we will see. So, do your cross multiplication. This time we start at the bottom and go up. 24 times the sine of 103, close it off, divided by 26. And we're expecting a decimal. There it is. We go out to 4 decimal places. 0.8994 is approximately the sine of B. To find an angle measure, what button do I use? The sine inverse. So second sine 0.8994, close it off, and I get 64.1 degrees. Now, for me, oh, this is actually B, isn't it? For me, I would now use the triangle sum theorem because it's quicker and easier. And if you notice, it's going to be a very small angle because 6 is a lot smaller than 24 and 26. So, for the measure of angle C, 180 degrees minus 103 degrees plus 64.1 degrees. And I end up with 12.9 degrees. Okay, so if you have the picture, you just kind of drill and kill. If you don't, the first thing you need to do is to draw the diagram, because it will keep you on track. You'll see what you've got and you'll see what you need to do. Okay, so angle B is 45 degrees. I know side B is 27. Side A is 28. So, what am I going to find first? Now, the first thing I have to do is find angle A. So the sine of 45 over 27 is equal to the sine of A over 28. Multiply that diagonal. 28 times the sine of 45 degrees divided by 27. And I'm expecting that decimal. And I get 0.7333 is approximately my sine of A. Sine inverse. Approximately 47.2. Okay, so now, oops, wrong one. That's A, not C. To find C, what is the quickest way? Triangle sum theorem is correct. (180 degrees minus 45 degrees plus 47.2 degrees is approximately 87.8. Okay, now what? Well, I've got to use this to find side C. So I still start with the one that I know, which is B, and is angle B and side B. So the sine of 45 degrees over 27 is equal to the sine of 87.8 degrees over C. Multiply at your diagonal. Sine of 87.8 times 27 divided by the sine of 45. And you end up with 38.2. Now, as I do a quick check, largest angle, largest side. Middle angle, middle side, small and small. So how do you know you're successful? You know you're successful when you can solve non-right triangles using the law of sines.